So I already went ahead and added the dipole markings to all of the bonds in this molecule. So you can see they're definitely, all the bonds, they are polar, they have a dipole to them. But overall, what happens is that, kind of like when you're looking at trigonal planar, this triangle part, these guys will cancel each other out because they are evenly separated going around the molecule. So it's like it's saying the molecule doesn't mind if there's electron density really close into the phosphorus or spread out, or like as long as you take all of those and you equally spread them out farther and farther away from the phosphorus, it's okay, and it's not considered to have a dipole. So then also these two guys here, you can kind of see that they cancel each other out. So there is no molecular dipole. So this is nonpolar. You can also see, if we're looking at our chart over here, are the outer atoms the same? Yes, so we'll go right. Are there lone pairs? That means on the central atom. And the answer is no. So that one does turn out to be nonpolar. So in this case, this is the most electronegative. Our dipole always goes towards the most electronegative. But this is extremely electronegative. So these two, you can actually see, are canceling each other out. Those two are. But this case right here, it's kind of like a fight going on between these, and it's an unequal fight. So overall, this is going to be heading towards this double bond, that electron density up there, and like with an overall thing, right? So this is going to be, the bonds are polar, yes, and the molecule is polar. And if we use our chart too, are the outer atoms the same? Yes. Go to the middle. Are there lone pairs? Yes. Go over here. Is the shape linear or square planar? No. And the reason those matter is because those are very, very symmetric shapes, and they usually have like matching bonds on the opposite sides. Okay, so right here, now in this case, we're looking at it and it's going like that. And then here's a ton of electron density overall. This is heading in that direction. These two here and here, they cancel each other out. So there's kind of like a fight going on between this bond and those electron pairs, but those electron pairs definitely hold the show. They're going to have a lot of density over on that side. So yes, the bonds are polar, and yes, the molecule's polar. And again, are the atoms the same? Yes. Are there lone pairs? Yes. Is the shape that? No, so it's polar. All right, we're finally to one of those funny shapes here. So in this case, because this is that triangle shape, and I know it might look like over here these two are really close together, it's just a drawing thing, how you draw it. These are like supposed to be a perfect equilateral triangle, so they're supposed to perfectly be distributing that electron density all the way around. And then over here, these bonds, yeah, they're both polar, but they are 180 degrees from each other, and so they also are kind of canceling each other out. So yeah, the bonds are polar, but the molecule is non-polar. And if you look over here again, are the outer atoms the same? Yes. Are there lone pairs? Yes. Is the shape linear or square planar? Yes, it's linear, and so it's nonpolar. All right, so now we're back to kind of the first situation where we don't have any lone pairs. If you're getting the sense for this, if you don't have any lone pairs and all the atoms are the same, you're looking at something that has all that electron density. It's all spread out evenly across the molecule. So yes, the bonds are polar. Is the molecule polar? Yeah. I'm sorry, no, the molecule is not polar. It's nonpolar. Because it's like these cancel, those cancel. Not cancel, but they spread the density out equally in opposite directions. So it's equally spread over the molecule. Same for this. They spread the density out in equal and opposite directions. All right, we got that right there. So major amount of electron density is going in this direction, even though, yes, that bond is polar. This one is canceled by this one. They're exactly 180 apart. And by canceled, I mean like they are equally, the electrons are spaced equally oppositely. So the molecule's not unbalanced. And same here. So yeah, the bonds are polar, but the molecule is also polar, because that electron density especially. It's kind of a fight here is where the fight's going on. And again for our chart, are the outer atoms the same? Yes. Are there lone pairs? Yes. Is the shape linear? Nope, it's not either of those, so it's polar. All right, and finally, this is a square shape, and now our electron density, so it's going in this direction and it's going in this direction, so they're equal and opposite, those lone pairs. So they actually are, they aren't doing anything to the molecule to unbalance the electron density. And then again over here, we're talking about balancing those two cancel each other out, and then those two balance each other out. So yeah, the bonds are polar, but the molecule is actually non-polar. And if you look over here on the right, are the atoms the same? Yes. Are there lone pairs? Yes. Is the shape linear or square planar? That's the other one, square planar. And if the answer is yes, then it's non-polar.